everyone. This is video 2 of 2 on integration by parts for Math 1452 at Texas Tech University, which is Calculus 2. So in the last video, we talked about the basics of integration by parts, how to identify our U and dv, and then we did an example of basic integration by parts. So in this second video, we are going to do examples of repeated and circular integration by parts. And what those are is that we have to use integration by parts twice to solve our questions, but we're going to use the integration by parts slightly differently if we're in the repeated case versus the circular case. So first off, we're going to do the repeated case. So in this example, we are integrating x squared sine of x, and we're using integration by parts. So first off, we identify the different parts of our integral, of our integrand. So our x squared here is a polynomial, and our sine of x is a trig function. So whenever we remember our acronym LIPET or LIPET, the P comes first, so that P is going to be our U. So our U is going to be x squared, and our dv is going to be everything else, which is sine of x dx. So now we're going to take a derivative of u. So the derivative of x squared is 2x, and then we add on a dx because we took a derivative. And now we integrate our dv. So we are integrating the sine of x dx, and the integral of sine is negative cosine. So remember here that even though we integrated, we don't need to worry about the plus c until our very last step. So now we are going to put this together into our integration by parts formula. So our integral of u dv was the integral of x squared sine of x dx. And now when we multiply u and v together, we're going to have negative x squared cosine of x. And then when we rewrite our integral v du, we're going to have negative 2x cosine of x dx. So again, the first thing I'm going to do is I'm going to make that double negative into a positive and actually add the integral of 2x cosine of x dx. And what we see here is that this integral 2x cosine of x dx actually is going to require integration by parts again. So this is not something we can use anti-differentiation on, and in particular, we can tell that because it's the integral of a product. And so whenever you see the integral of a product, that's a good indication you're going to have to use integration by parts, because remember, integration by parts undoes the product rule. So we have our first part of 2x and our second part of cosine. So again, identifying these parts, cosine is a trig function and 2x is a polynomial. So again, using our acronym LIPET, our u is going to be that 2x. And our dv is going to be everything else, which is cosine of x dx. So now we just do the process over again. So we take the derivative of 2x, which is just 2 dx, and we integrate dv, which is the integral of cosine of x dx. And when we integrate cosine, we get positive sine. And then we just put that into our formula. So our integral of u dv that we started with was the integral of 2x cosine of x dx. And now our u times v is 2x sine of x. And our integral of v du is going to be 2 sine of x dx. So now, even though this is still a product, the integral of 2 sine, our 2 is a scalar multiple, and that does not impact the integral. So this is really just integrating sine of x to give us negative cosine, and then multiplying that by 2. So just to simplify that, this is 2x sine of x minus 2, and the integral of sine is negative cosine. And then now we are going to see. So first thing I'm going to do is I'm going to make that double negative into a positive. So this is 2x sine x plus 2 cosine of x. And then I'm going to add c. So we need to put both of these steps together. So we initially wanted to figure out the integral of x squared sine of x. And based on our first step for integration by parts, that's negative x squared cosine of x plus the integral of 2x cosine of x dx. And our second integration by parts let us rewrite that second integral. So this is really equal to negative x squared cosine of x plus 2x sine of x plus 2 cosine of x plus c. So depending on how you are entering these questions, you could leave it here. And if you're using WebWork for your homework, WebWork will take this as an acceptable answer. However, if your instructor wants you to rewrite and simplify this, we can look at our common terms of our cosine here. And we can say that, well, cosine has a negative x squared plus 2 coefficient. So that's the only really simplification you could do here. But like I said, if you're using WebWork for your homework, this is an acceptable WebWork answer, either of the last 2 lines. Okay, so this is a repeated integration by parts. We just noticed that whenever we rewrite our integral as v du, it's again something that's a product that we need to undo. So let's look at our example for circular integration by parts. So for circular integration by parts, it's going to repeat integration by parts, but our solution will just look a slight bit different. So first off, we look at our integral. So here we're integrating e to the x times sine of x. And again, we see this as a product, good indication to use integration by parts. And we identify the parts of our integral. So this e to the x is an exponential, and our sine of x is our trig function. So if we look at our acronym limit, the e comes before the t, so we're going to have our u be e to the x, and our dv be everything else, which is sine of x dx. So now we take a derivative of u, and we are going to get that the derivative of e to the x is still just e to the x. Then we add a dx. And then we are going to integrate our sine, and the integral of sine is going to be negative cosine. And remember, we're not worrying about the plus c here. So now we are going to rewrite our integral using the integration by parts formula. So we started off with the integral e to the x sine of x dx. And when we multiply u and v, we get negative e to the x cosine of x. And then we rewrite our integral as the integral of v du. So this is going to be negative e to the x cosine of x dx. So the first thing I'm going to do is I'm going to make that double negative a positive. And I'm going to look at my new integral. So my new integral is still a product of e to the x times cosine of x. So again, I am going to use integration by parts on this product. So our cosine of x is a trig function, and our e to the x is our exponential function. So again, the e comes before the t, so my u is again e to the x. And my dv is everything else, which is cosine of x dx. So now we take a derivative of u, and we get that the derivative of e to the x is e to the x. And when we integrate cosine, we are going to have that the integral of cosine of x is positive sine. And now we put that into our integration by parts formula. So the integral of e to the x cosine of x dx is going to be equal to u times v, which is e to the x sine of x, minus the integral of v du, which is going to be the integral of e to the x sine of x dx. So now that we're here, we again look at our new integral. So our integral that's new here is the integral of e to the x sine of x. And so we can say, okay, well, we need to do integration by parts again because it's an exponential times a trig function, but we can pause and say, wait, that was our original integral that we were looking at. So whenever we're doing circular integration by parts, what's going to happen is that whenever we use integration by parts a second time, we get back to the integral we started with. And when we have arrived back at our original integral, we can stop and just use algebra to figure this out. So again, just like with repeated integration by parts, we're just going to write down everything we know and combine these equations. So the integral of e to the x sine of x, based on our first integration by parts, was negative e to the x cosine of x plus the integral of e to the x cosine of x dx. However, using our second integration by parts, that second integral was equal to e to the x sine of x minus e to the x sine of x dx. So now we're solving for this integral. So what we're going to do is we are going to add that integral to both sides of the equation. And so whenever we do that, when we add it here, on our left-hand side, we're actually going to have two versions of that integral. So just that integral times 2. And then on my right-hand side, I'm just going to have negative e to the x cosine of x plus e to the x sine of x. And now, to solve for my integral, I am going to just divide by 2. So the integral of e to the x sine of x dx is just going to be 1/2 times what was on my right-hand side, negative e to the x cosine of x plus e to the x sine of x. And then, as we've mentioned before, as our very last step, we can add the plus c. So this is what we get for our circular integration by parts. So once we get back to our original integral, we can just use algebra to solve it. Okay, so that is going to be it for the video series on integration by parts. Thanks and good luck.